Hi all, in today's session, we are going to see how to classify text using naive bias. So for this, I have downloaded a spam.csv file. You can download it from Google. And these lines import various libraries and modules required for data manipulation, visualization, evaluation metrics, and machine learning algorithms. And libraries such as Pandas, Matplotlib, NumPy, Scala, and Seaborn are imported to support different aspects of the project. And here we are reading the CSV file named spam.csv using the Pandas library, and it is getting stored in a data frame called A. And this R before the file name is used to treat the string as a raw string, preventing backslashes from being treated as escape characters. And using this A, we are displaying this data frame. This is useful for visually inspecting the loaded data. And coming to this line calculates the sum of missing values for each column in the data frame A. It helps identify the number of missing values in each column because basically we have to do some analysis before getting into the project. We have to do some data pre-processing also. And these lines create an instance of label encoder because it is used to transform this category column of the data frame. This category I'll show you. Okay, here. This category column of data frame A into numerical labels. I'll show you the transform label. After encoding, can you see? The transform labels are stored in Z1 and then assigned back to the category column in A using these lines. This step is essential for converting categorical data into a format that machine learning algorithms can work with. And these lines extract the message column as the feature, that is X1, and the category column as a target Y1 from the data frame. And then we are using this line. We are splitting the entire data into training and testing sets. It divides the message column, this entire message column, into training and testing subsets while maintaining the corresponding category labels. This parameter test underscore size is equal to 0.2. It specifies that 20% of the data will be used for testing and random state is equal to 20. So it's a random state for reproducibility. Then xtrain.values and ytrain.values, these lines display the values of the training features, that is xtrain, and training labels ytrain arrays. This step is for visual inspection and understanding the data. And we are using count vectorizer. This line initialize a count vectorizer object B and then use it to transform this training text data, that is xtrain, into a sparse matrix of feature vectors, that is xtrain 2. This one. This count vectorizer converts the text data into numerical format by counting the occurrences of words in each message. Then here a multinomial naive Bayes classifier A1 is created. I'll show you where we imported this multinomial NB. Can you see here? Yeah, okay. From sklearn.naive Bayes, we have imported this multinomial NB. Okay. This is trained using the transform training data extrained to and the corresponding training labels Y train. This fit method trains the classifier. Then these lines, they use a previously initialized count vectorizer B to transform the testing text data, that is X test, into numerical feature vectors, that is X test 2. This ensures that the testing data is represented in the same way as the training data for prediction. Then coming to these lines, okay, this line, it transforms the testing text data, that is X test, using this CV count vectorizer B, and then uses the trained multinomial naive Bayes classifier, that is A1, to predict the categories of the testing messages. Here, this predict method returns the predicted labels. And here, I have given some random words. It's in a list format. And this line defines a set list of example text messages, and it is stored in B. The count vectorizer B is here. B is used to transform these example messages into numerical feature vectors, that is F, to prepare them for prediction using the trained classifier. And finally, this line predicts the categories of the example messages in F using the trained multinomial naive Bayes classifier, that is A1. Here, this line calculates the accuracy of the multinomial naive Bayes classifier A1 on the testing data. This core method computes the accuracy by comparing the predicted labels with the actual labels Y-test. So this is a simple program for text classification using naive Bayes algorithm. Thank you.